there everyone, my name is Graphics. If you look at the top right corner of your screen, you see a question there, and the question is under what? Linear friction, and this is what? A double side inclined plane. Now in this question we are told to find the acceleration of the block and also the tension between the string, the tension in the string of that is connecting the two blocks together. Now if you look at it, let me redraw this so you see what I'm trying to talk about. Now this is what we're having. This is the string connecting the two blocks, and you know when you pull a string, it develops a tension, right? Now if you look at this now, this block you see here will tend to flow through this direction due to the much weight of this. This is 200 Newton compared to what? 50 Newton. So it will go in terms of what? A clockwise movement. So it will pull this to the other side. So because of that, there's a tension here. So we say the tension here should be giving us T, let me say T2, or let me call it T1, right? And here should be what? T2. Let me put it that way. Now because of this is a pulley, right? So it makes there should not be friction between the string. So it means that because of the pulley, we say that the T1 is equals to what? The T2 is equals to what? T. So they are all the same tension will be experienced throughout the string. Are we together? Now if you look at this T2 means that we'll be having coefficient of friction mu to be equals to what? 0.25. That is, I'll call it T mu coefficient of friction 2. We are dealing with this side is 2, here is what? 1. Now we move forward. We have what is called W2, which is the weight, and that is giving us 50 Newton, right? So similarly, we also have what is called the theta, the angle. So I'll say theta 2 is giving us what? 45 degrees. Similarly, we're talking about 1 now. So we have coefficient of friction of that 200 Newton block is going to give us what? 0.12. Also, the weight of that 200 Newton block is giving us what? W1, and that's giving us what? 200 Newton. And also we have the angle of inclination of the inclined plane of that 200 Newton block. We call it theta 1, and that's giving us what? 30 degrees. Now these are our parameters that we have, right? So now in this case here now, let's see what will happen. From here we want to consider this side because we assume that the block is moving towards direction due to the weight of this block here is bigger than this. So now we say consider the 200 Newton block. So let me do it here. Considering 200 Newton block. Alright, that we want to consider. So we'll draw that. So in drawing that, we'll be having something like this. Now this is what we have here. This is 200 Newton what? 200 Newton block here. Now it tends to what? Slide down. Now what do you notice? If you slide it down, that will tell us that what is motion of the block down the inclined plane. So what I'll do is I'm going to put that recall. Right? Recall motion down inclined plane. Right? You watch my previous video, I explained this. It's giving us what? The summation of f of x equals to what? W sine theta 1 sine theta 1 plus minus W, or we'll call it mu W cos theta. Right? Let me move the theta 1 for now. So this is the relationship here. If you watch my previous video, I explained this and I proved how we got this. Now, we know we are dealing with component 1 as in 1 here. So we can put it this way and say that recall summation of f of x will give us what? Mass times acceleration. That is what? Second law of motion. Is that okay? So move forward. So anywhere I see my summation f of x, I'm going to put what? ma, right? But the ma I'll not put in, I'll put m1a because I'm dealing with what? Everything involving this is for 1, the subscript is 1, and here is what? 2. So giving us the w here is giving us 200, that is w1, giving us what? 200 Newton, and sine the theta here is giving us what? 30 degree, minus the mu is giving us 0.12, the w is giving us what? 200 cos 30. So this is what we have. So because this will be w1 theta 1 mu 1 w2 and theta 2. So that's what we are dealing with here now, right? So from here, if I punch my calculator, now because of that, this is what we have, right? Now what do you notice? There's a tension on this string due to the weight of this block. So it means that the magnitude of the weight is causing the tension in the string. So you are going to subtract the tension from the force going downward. And what is the force going downward? The force going downward is everything that you have here. So I'm going to subtract it from what? From the tension, minus what? Minus T. Right? So I'm going to subtract this one you see here from what? From negative T. Are we together? Now, we will now move forward. Punching the calculator here, we'll say 200 sine 30 is giving us what? 100. And we have my mass, 1 times what? Acceleration. Minus, we have 200, that is 0.12 times 200, multiplied by what? Cos 30, is going to give us 20.785 or 20.79. So we have 20.79 minus what? Minus the tension. Right? Now, we don't know what the mass is, but we can easily detect the mass. So recall our weight is equal to what? Mass times what? Gravity. And we know that our gravity is given as 9.81. So if I want to get my mass will be given as what? Weight all over what? All over gravity. So what is the weight of this block we're considering? Is 200. So the mass here begin as what? 200 all over what? What is the gravity? 9.81. So if you divide 200 divided by 9.81, you'll be having 20.38 or 20.39, right? So we're having 20.39. So let's do that. So my mass here now is what? 20.39 kilogram. That is the mass. So we move forward. So that means we call it, this is W, that will now be M1, W1, and G is a constant. So we'll put it. Since I'll be writing my M1 here now, I'm going to put 20.39A equals to 100 minus 20.79. So 100 minus 20.79, that will give us 79.2. So this minus will give us what? 79.21 minus what? Minus T. So I will make the tension, sorry for the formula here because we are looking for what? The tension. So if I put it here, it means that if the T should come to this point, it will be T equals to 79.21 minus 20.39a. When it comes to the other side, it will become negative. So I'll term this to be what? My equation 1. Are we together? So we've considered the first block. Now we're going to consider the second aspect. So we'll consider what? The 50 Newton block. So I'll write it this way, that considering the 50 Newton block, right? So let's consider it and see how it goes. If you look at the top right corner of the screen, we're considering the angle of 45 degrees. So I'm going to have something like this. So I'll have my horizontal ground this way, and this particular guy going up this way, right? Then the angle in between here is giving us 45 degrees, and the block is standing here, right? Then this is my horizontal ground here, right? Now if you notice it from our analysis here, let me show you this. From our analysis here, this is motion down the inclined plane. Is in this case the block is sliding down, but in this case now, as a result of this sliding down, this is what? This is moving up, right? So this is motion up an inclined plane. So if you want to do that, from my previous video, you put it this way, this is not going up the inclined plane, right? It's moving up the inclined plane. So what we'll do, I'm going to say that recall the motion up inclined plane, right, will give me the summation of f of x equals to what? W sine theta plus, become plus now. The first one was down, so it's negative. This one is up, so the plus, then mu w cos theta, right? Now what do you notice? This guy here, right, the magnitude of this, where the tension here is greater than what? Than this force. What am I trying to say? Here now we said something, that the weight here is greater than, is the result of, is what is causing the tension. So it is this weight that is making this tension to exist, right? So it means it's greater. So we're subtracting whatever we have from PT from whatever we have. Now in this case here now, we are pulling it up, so it means that the tension is greater than the force here. So what we'll do, we'll now say that therefore the summation of f of x will give me the tension minus what? W sine theta plus mu w cos theta. So this is what we have in here. Put this into brackets. So the first one, we're subtracting tension from what we have. Then this one, we're subtracting what we have from what? From tension. Now in this case, we say that, recall, we know summation of what? F of x here is the force, is equal to what? Mass times acceleration. So everything we are dealing here will now be what? 2, 2, 2, 2, and 2. Can put it that way. Now the T1 equals to T2, so I don't have to change this guy. So I'll put it, this will give me the mass times acceleration, this is m2, equals to the tension minus, we have W is given as what? 50, W2 is 50, sine theta 2 is what? 45 degree, considering the 45 degree. Then plus the mu here given, the mu 2 is given as 0.25 times W2, which is what? 50 cos what? Cos 45. So from here we are going to be having this to be t minus, open the bracket, 50 sine 45, 50 times sine 45 will give us 35.36 plus cos 45 times 50 times 0.25, and that will give us 8.84. So we have 8.84. So we move forward. At this case here, this is still giving us t minus 8.84 plus 35.36. that will give you 44.199. So we have 44.199, right? So this is what we have here, and this is my M2. M2 here will be given us, from here we'll say that M2A is equal to this, right? So we'll move forward to our next guy here. So what we have here, recall the weight is equal to mass times gravity. So we're talking about weight 2 and what? Mass 2. So the mass 2 will now giving us what? Weight 2 over what? Gravity, right? So our mass 2 here now will now give us, the weight 2 here is 50 and the gravity is 9.81. So if I divide 50 divided by 9.81, I'll be having 5.097. So M2 here giving us what? 5.097 kilogram. So we input it into the equation above. Which equation? This equation here. So anywhere I see M2, I put 5.097. So to be 5.097A, so we say that therefore 5.097A equals to T minus 44.199. T minus 44.199. Right? So if I make T the size of the formula, T now will now be equals to 5.097A, right, plus 44.199, because when it's coming here become plus. So this is what we have here, but we said that T is equals to what we did earlier, and that is what? 79.21 minus 20.39. So we have 79.21 minus 20.39a. 20.39a. So we put it here. So this will now be, therefore we now have 79.21 minus 20.39a equals to 5.097a plus 44.199. So we've done that to collect like terms. So here will give me 79.21 minus 44.199 equals to 5.097a plus 20.39a. So from here, if you add this, we have 79.21 minus 44.199 0.199, that gives us 35.011 equals to, we have 5.097 minus 5.097 plus 20.39, and that gives us 25.487. we have 25.487a. So if I divide both sides by 25.487a, so it means that a will be giving us 35.011 all over 25.487. So my a here now give me 35.011 divided by 25.487, that give me 1.37. so 1.37 meter per second square. That is the acceleration, right? Now we've gotten the acceleration here, so for we to get the tension, so I'll put it this way: calculating for what? For tension T. So you substitute A into either equation 1 and equation 2. Where's my equation 2? This is my equation 2 here. So anytime you put your value, so substitute A into equation 1. Let's do that. So substitute A equals to 1.37 meter per second square into equation 1. So what's my equation 1 here? My equation 1 here is giving us T equals to 79.21. T equals to 79.21 minus 20.39a. 20.39a, right? So if I put my a, the T here will now give me 79.21 minus 20.39. What is the a? 1.37, right? So the T here will now give me 79.21 minus 20 times 20.39 times 1.37. That will give us 20.28.00, right? So T here will now give us minus 79.21, give us 51.2 Newton. That is the tension. Tension is what? 51.2 Newton. So that's our tension here. So if I place my A still in equation 2, I ought to get the same answer. So let's see. Let's try for other equation. Trying for equation what? Equation 2, right? So it's not necessary, but I just want to just prove, because in the beginning we said something that what, due to what, the pulley, T1 is equals to what? T2. So equals to T. So my T1 and T2 must be the same. So that means the tension at both sides must be the same. So let's check that and see from this our equation here. So substituting to equation 2. So what's equation 2 here? Equation 2 here is given as what? T is equal to 5.097a. We have T equals to 5.097a plus 44.199. So if I put in my A, T will now give me 5.097. What is A? 1.37 plus 44.199. So the T here will now give me, you multiply these two, you have 6.983 plus 44.199. So T will give us 51.18. So give us 51.18 Newton. So approximately 51.2. So what do you notice? The T1 is equal to what? T2. You have the same value, right? So your acceleration should not be negative. It should always be what? Positive. So if you find this video helpful, please don't forget to click on the subscribe button and also click on the notification bell so that when I upload more videos, you're going to get a notification. Thanks for watching.